All right, so section 3.4, applications of systems of equations, okay? I know when people see these types of problems, the very first thing they think of is, oh my gosh, just skip it, okay? Just skip it. Hopefully it doesn't come out on the test. Unfortunately, this homework is 6 of these. So I'll try to see if I can get 3 of them done for you, and then you guys do 3 on your own, okay? Um, Now, my main focus is to read the question once and then try to identify where does my first equation come from, where does my second equation come from, what is my goal, okay? Now, we've been doing systems of equations, so that means we may have to graph, we may have to do elimination, we may have to do substitution. It kind of depends on you, whatever you want to do, okay? But it's not terrible. These problems are not terrible, okay? They're very straightforward. You just got to identify what's important, okay? And that's what I'm going to try to help you with. So we'll just start off with the very first problem, okay? So here we go. Very first problem. Here we go. New York City is a popular field trip destination. I'm just going to read it, okay? This year, the senior class at High School A and senior class at High School B both planned trips there. The senior class at High School A rented and filled 1 van and 2 buses with 117 students. High School B rented and filled 4 vans and 12 buses with 668 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? Okay, so I know that that's like, what am I supposed to do, right? Our objective is to figure out how many students can be in a van, how many can be in a bus, okay? But first we got to build up our equation. So, can I write an equation from the first sentence, which says, New York City is a popular field trip destination? No, there's nothing there. It's just, hey, it's New York, right? Now, is there anything important in the second sentence that makes me build an equation? Let's see. This year, the senior class at High School A and senior class at High School B both planned trips there. Is there anything there that says, oh, 3x plus 5y? Like, do you see anything there? No, right? Okay. So the first 2 sentences so far have kind of been distractions, right? Kind of been distractions. All right. The next part. The senior class at High School A rented and filled 1 van and 2 buses with 117 students. Does that look like I can make an equation out of that? Yeah, so let's see. I'm going to highlight this one, okay? Senior class. So here's one equation right here. So this is what I'm going to do. I'm going to reread this. Senior class at High School A rented 1 van and 2 buses with 117 students. Now, by the way, what was it that I was supposed to find? Let's see. How many students are in a van? How many students are in a bus? What do you think my variables are going to be? Or maybe not variables, but what is it I'm trying to figure out? What are the words that I'm trying to like solve for? A van and a bus. So are we cool if we use a V and a B for variables? Right? Vans and buses, a V and a B, right? So how can I write that yellow sentence there? Senior class High School A rented 1 van and 2 buses, right? 2 buses. So 1 van plus 2 buses with how many students? 117. Now, remember, V is how many students are in a van. B is how many students are in a bus. So V plus 2B, that's how many students are in a van plus how many students are in 2 buses. That equals to 117 students. Okay, they tell me that in that yellow sentence. They're not trying to be cryptic. They're not like, ooh, let's mess them up, right? They literally said 1 van, 2 buses, 117 kids, right? Let's look at the next sentence. High School B rented and filled 4 vans and 12 buses with 668 students. Can someone give me the equation for that one? 4 vans, 12 buses, 668 students. So B equals 668. Good. There you go. I have 2 equations, right? I can solve. Okay? Isn't that the hardest part to word problems, right? That's what students always tell me. They always say, I don't like word problems because I don't know how to set up the equations. They always tell me, if you give me the equations, I can do the work. But it's getting it there. That's the hard part, right? But notice, we just did that. And then that sentence I didn't underline says each van and each bus carried the same number of students. Well, that's fine. They will all carry an equal number of students per bus per van. But it says how many students can a van carry? How many students can a bus carry? So I'm going to use elimination if you guys don't mind. Okay, I'm going to multiply the top equation by 4 because I want to get rid of my v variable. Okay, I'm going to bring out my calculator really quick. So, okay, so if I do that, I'm going to get 4v plus 8b equals 117 times 4, that's 468. And then I have 4v plus 12b equals 668. What should I do to get rid of the v? Add or subtract? Say it louder. Yeah, subtract. Okay, we're going to subtract. 4v minus 4v cancels. 8b minus 12b is negative 4b. And 468 minus 668 is equal to negative 200. So if I divide both sides by negative 4, I'm going to get b equals 50. So how many students can a bus carry? 50 students, right? Now I just got to figure out how many the van can carry. So let's see, how many can the van carry? I'm going to use one of these 2 equations in the very beginning. I'm going to pick this one right here, okay? This one looks like it's easier to do. All right, so v plus 2 times b, which is 50, equals to 117. So v plus 100 is 117. If I subtract 100 on both sides, what's my answer for v? 17. So did I answer the green question? How many students can a van carry? How many is that? 17. How many students can a bus carry? 50. And we're done. Guys, word problems are tough. I'm not going to lie. They are tough. But if you break them down slowly, see, that's the problem that a lot of students do. They try to swallow all of that. It's like eating a Big Mac in one bite, right? I'm kind of weird when I eat a Big Mac. I actually eat it half and half. I don't know if you guys know what I mean, but I get, it has 3 breads. I take the top 2 and I eat that first, and then I eat the bottom one second. Why? I don't know. I've done it like that since I was a kid, and I have not gotten over that. Can I eat it normally? Sure. I don't know why. I'm stuck that way. But anyway, you can't really, I guess some people can, but you really don't want to eat a Big Mac in one bite. You want to eat it little by little, right? So that's the same thing with word problems. Don't try to digest all of this at one time. Take your time, see what's important, okay? All of this stuff up here, this is all just a distraction. This is a distraction to make the problem look longer and mess with your heads. Okay? That's all it is. They're just trying to put a story into the problem. But it's not important for you to do that story in order to do the problem. Okay? It's just the setup. But then you have to find, okay, where is the information, right? So there was the information. I highlighted it for us. Okay, the yellow, the blue, that's where we got our equations from. The green, that's going to be what is my goal. Okay, what is my goal? So I'm just going to write this really quick just to make sure. Bus carries 50 students and van. Now I'm just doing this for my own good, okay? Carries 17 students. Just so that I have a place where I wrote the answer so that it makes sense, okay? Any questions on this one? Anything that you guys maybe want me to clear up or anything like that? Notice we're using the same stuff that we've been doing. We're just now taking it from a word problem. So, all right. I don't know. Maybe I'll just do the first three. Let me see if the last three are any like more difficult. Oh, look, 4 is just a bus problem. Okay. Buying problem. Oh, maybe I'll do the first three because it looks like the first three and the last three are kind of like the same thing. So we'll do the first three. You guys do the last three. Okay. So, all right, here we go. Next one. The school that Eduardo goes to is selling tickets to a play. Now, do I need that sentence to set up an equation? Does that look important? No, right? Like, it's just, okay, that's the story. On the first day of ticket sales, the school sold 12 senior citizen tickets and 6 student tickets for a total of $258. Does that sound important? Yeah, right? There's numbers there. So I'm going to highlight that with yellow. Okay, that's my first equation. That's my first equation. Then it says, the school took in $142 on the second day by selling 6 senior citizen tickets and 4 student tickets. Does that sound like it should be an equation? Yeah, right? So let's highlight that one in blue. Okay, now in green is, what do I need? What is the price of each one senior, so I guess they mean, what is the price of one senior citizen ticket and one student ticket? That is my goal. Okay? So there's a school that's selling tickets. On the first day, they sold a certain amount. On the second day, they sold a certain amount. They want to know how much does each ticket cost. Okay? Again, don't try to take this all at once. I'm trying to separate it for you guys. Let's focus on the yellow text. Okay? Yellow text. It says on the first day of ticket sales, the school sold. Actually, hold on. Before I focus on the yellow, let's look at the green. What is the price of one senior citizen ticket and one student ticket? What variables can I use? I don't care. You give me whatever you'd like. For senior citizen, what should I use? Don't use S though. A C. All right. So we're going to use a C for senior citizen. And for student, I don't want to use S. Any other letter you can think of? I mean, anything's fine, but maybe something that makes sense. How about like the letter P for pupil? Right? Sometimes students are called pupils. Right? I don't know. Whatever. So we'll use C and P. C for senior citizen and P for pupil, for student. Okay? All right. Now that we have that in our head. On the first day of ticket sales, the school sold 12 senior citizen tickets. So let me write down this one. 12 senior citizen tickets and 6 student tickets for a total of $258. All right, there's my first one. Can someone tell me the second equation in the blue section? Anybody? It says the school took in $142 on the second day by selling 6 senior citizen tickets and 4 student tickets. What should I write? I'll start off a little bit here, see if I can help. Good. Yeah, there you go. I mean, does this seem like, oh my gosh, this is way too difficult, I can never do it? I mean, it really isn't, right? Just break it down. All right, I'm going to have to solve, okay? But right now, none of the numbers in the front of the letters match up, so I'm going to force them to match. So what I'm going to do is I'm going to multiply the bottom one by 2, because 2 times 6 is 12, right? I can eliminate the C value, okay? So I'm going to multiply by 2. Let me rewrite this. 12C plus 6P equals 258. And then when I multiply this is 12C plus 8P equals, what is that? That's 48284. So are we good so far? All right. And again, if you're taking notes, that's fine. If you want to write this down. But if you want to write down the problem, do that later. Okay? Do that later. So, how do I get rid of the 12 C's? Should I add or subtract? I got a 12C and a 12C. By adding or subtracting? Subtracting, right? So here we go. So 12C minus 12C, that's gone. 6P minus 8P, that's negative 2P. Now, let me use my calculator here. What do they call it in Blue's? Did you guys ever watch Blue's Clues? Were you guys old enough for Blue's Clues, or you got no? What did he used to call his calculator? You guys remember? He called it the handy dandy calculator. I still remember. I used to watch that show way too much when my kids were little. But here we go. Minus 26. That's my answer. 258 minus 284 minus 26. If I divide both sides by negative 2, I get that P is equal to 13. So how much money does one student ticket cost? 13 bucks. Right? I just got to figure out the senior citizen ones. Okay? So I'm going to use one of these equations right here. Okay? One of those. It doesn't matter which one. Which one would you guys prefer? The top one or the bottom one? Which one looks easier? Bottom, right? Okay, so here we go. Bottom one. So I'm going to plug in P equal to 13 into the bottom equation. Okay, I'm going to use purple here. So 6C plus 4 times 13, that's going to be in red because that's what I'm plugging in, equals to 142. So 6C plus, what is that, 52 equals to 142. Just so Mr. Webb knows, I'm having them not take notes because of word problems, so that's why I'm working a little faster, because I know they're just looking, they're not having to chase me. So yeah, in case you're like, man, he's going quick. That way at least Mr. Webb knows. So I'm going to subtract 52 on both sides, right? Minus 52. So if I'm correct, that should be 90. Yeah, should be 90. So if I divide by 6, C is 5. No. What's 90 divided by 6? Is it 15? Yeah? Oh, I was going to say 15, but I'm like, no, that's not right. So it is 15. Okay, cool. So there you go. The senior citizen tickets are $15 and the student tickets are $13. Okay, so I'm just going to write that down. Senior citizens are $15 and students, they're $13. Okay, and you can see the answer would be B for this one right here. Questions on this one? You guys have any questions on this one? Does it help that I'm color coding these things to break it down for you so you can see focus on yellow, focus on blue, green is your goal, right? So same thing like we did the other one, right? Focus on yellow, focus on blue, but green is your goal, right? The rest of the sentences, they're just distractors, They're there to set up a story, right? So at least what you're doing kind of makes sense, right? We're selling tickets, so this is why they're giving us this information, right? They're not just throwing numbers at you and saying solve, but at least you get a story behind. So remember, there are 6 problems, okay? 6 problems. I'm going to have you guys try something later on, but before you leave, I kind of want you guys to at least try to get one of these done, okay, before you leave. But let me do number 3, and then I'll have you guys work on number 4 by yourself, okay, and see if you can give me an answer. And I'll kind of walk around and check to make sure you guys are understanding it. But number 3 looks like a handful, right? I mean, this is a lot. But again, a lot of it could just be stuff that they're trying to distract you with, the storyline, right? So here we go. Let's read through it. It says Jennifer and Gabriella are selling cookie dough for a school fundraiser. So far I know there's 2 girls. Customers can buy packages of chocolate chip cookie dough and packages of double chocolate cookie dough. So now there's 2 types of dough. Okay, so what are they wanting me to do? Jennifer sold 9 packages of chocolate chip cookie dough and 2 packages of double chocolate chip cookie dough for a total of $169. Gabriella sold 1 package of chocolate chip cookie dough and 13 packages of double chocolate chip cookie dough for a total of $236. Find the cost of 1 package of chocolate chip cookie dough and 1 package of double chocolate chip cookie dough. My objective is usually pretty easy to see. It's at the very end. So I'm going to highlight it right now. The reason why I'm telling you to highlight it now is because we got to give it variables. So chocolate chip cookie dough, let's just call that C. What do you want to call double chocolate chip cookie dough? D, right? I mean, it makes sense for double, right? So we have C and D. C for chocolate chip and D for the double chocolate cookie dough, okay? So keep that in mind. So we're going to reread this again, then we're going to ask ourselves, is this important? So is it important that Gabriella and Jennifer are selling cookie dough for a school fundraiser in terms of building an equation? Is that important? No, I don't get anything from it. There's no numbers or anything, okay? So who cares? Customers can buy, this second sentence, customers can buy packages of chocolate chip cookie dough and packages of double chocolate cookie dough. Is that going to give me an equation? No, so who cares about that? Next one. Jennifer sold 9 packages of chocolate chip cookie dough and 2 packages of double chocolate cookie dough for a total of $169. Does that sound like it has information? Yes. So I'm going to highlight that for us. So Jennifer sold 9 packages of chocolate chip cookie dough, 2 packages of double chocolate cookie dough. I know it's super wordy, but we're just going to break it down little by little. So let's write the first one, and then let's see if you guys can give me the second one. 9 packages of chocolate chip cookie dough, so 9C, and 2 packages of double chocolate cookie dough, plus 2D, and the total was 169. All right, so there's my first equation. Again, I know word problems are tough, but if you break them down little by little, they're actually pretty easy to do. You just read the sentence and write out what you see. Second sentence that we're going to look at, or the blue one, is Gabriella sold 1 package of chocolate chip cookie dough and 13 packages of double chocolate cookie dough for a total of $236. There's a lot of information there. So that's going to be my second equation. Remember, the green is the main question that the problem wants us to solve for, right? The yellow and the blue are going to be my equation. So can someone give me the equation for the blue line? Gabriella sold 1 package of chocolate chip cookie dough, 13 packages of double chocolate cookie dough for a total of $236. What's that equation? All right, so there we go. And we're done. We have our setup. Okay? We have our setup here. So what I'm going to do now is go ahead and start solving. Which letter do you think I want to get rid of? Which one do you think might be easiest to make match? the C, right? Because I just got to multiply that bottom one by 9. So here we go. Multiply by 9. Okay, so here are my new equations. 9C plus 2D, and give me a second. All right, so sorry about that, guys. It's just technical difficulties, right? So 9C plus 2D. I'm just rewriting the top equation, equals 169. And the bottom equation is going to be 9C plus 9 times 13, that's 117. I think that's right. Yeah, 117. And then 236 times 9 is 2,124. So to eliminate 9 C's, I'm going to subtract, okay? We'll subtract, and this cancels. 2 minus 117 is negative 115D. And 169 minus 2124 is negative 1955. Okay? So if I divide both sides, I get negative 115 on both sides here being divided. So D is equal to 17. That's how much the double chocolate cookie dough costs. $17. Okay? So all I need to do now is figure out how much the chocolate chip one is. You go back to your original two equations, these two right here, and you pick whichever one you feel is easier for you. I'm going to pick the bottom one because this one has a C all by itself. Okay? So I'm going to pick the bottom one. So C plus 13D, which is 17, that's my answer, is equal to 236. Now 13 times 17, let me put that here. I'm just putting that in my calculator. That's 221. And if I subtract 221 on both sides, my answer comes out to 15. So minus 221. C is equal to 15. So the chocolate chips cost 15 and the double chocolate cookie dough cost 17. If you notice, that's part A, right? The answer A would be the right one. I'm just going to write it out for us. So chocolate chip cookie dough, I'm going to just put CCCD, is $15, and double chocolate cookie dough is $17. Okay? And that will be my answer. And that's the lesson for today.